Yeah, am I audible?
Yes.
Good morning, ma'am.
Good morning. So in the last session, we have discussed on introduction to different types of protocols, right? In system on chip level and also in IP level, what are the different protocols are used? So I told you to do some work on protocols and related its features, right? Did you all gather that information? No? I told you to check for uart, I2C, APB, AHB, AXI, PCIe, and USB. Just classification of all protocols. Have you tried that?
Not all.
I2C, huh? Fine. Others, what about
Opportunity to go through the protocols and understand the basic.
protocols or serial and high speed, low speed, full duplex, half duplex, and intra assignment, inter assignment? Did you all understood the differences why some protocols are under some classification and remaining? Did you got the idea exactly? So, and where we use different types of protocols application wise, or still any doubts? If you have any doubts, we'll discuss today.
We didn't get the recordings yet for the yesterday's session.
Okay.
So can you share it when you're?
Okay,
Mm,
I already shared to few students, but I didn't share it in groups. I will share it again.
yeah, please. Thank you.
Next, no doubts. So shall we move to yacht today? As per our schedule, first we need to start with the introduction to protocols. So yesterday we have discussed introduction to all protocols, and today we are going to start with the uart. Today we will learn specification of uart, like why do we use uart, and the frame format, how the transmitter and receiver structure, and how we calculate the frequencies, baud rate. So you already know your protocol is a asynchronous, right? That means we don't use the common clock between transmitter and the receiver. So that's why we will make synchronism between transmitter to receiver using the baud rate. Okay, so we will look into that with some examples. How can we calculate the baud rate, and how the transmitter and receiver block diagrams are written. And in the next session, we are going to discuss on how to design overall UART protocol, the transmitter, receiver, baud rate generator, RTL design, and also verification. Okay. So today we'll start. Uh, so first of all, what is meant by UART protocol? UART means universal asynchronous receiver transmitter. We also have UART version in UART. UART in the sense universal synchronous asynchronous receiver transmitter. In that we use a clock, but in UART we don't use the clock. Okay, so coming to the features of your protocol, what are the best features of your protocol? Already we discussed yesterday whether it is communicating within the chip or outside the chip. Your protocol means it's a port, right? Port is different. Signal to signal connection is different. Component to component. Mostly component to component or I2C SPI. Port these type of ports, that mean UART, USB. These all are ports. If you see in your laptop sites, there will be blocks, right? Like a ports we call. We connect with the external devices. Okay, so UART comes under port, not like a internal block to block communication. Okay, so USB is a present trend, but compared to USB, UART is a basic version, very basic, like a starting fast protocol. That's why even we don't have clock in the UART. Okay, so coming to the features, what are the major features we have for UART? In the sense, first, asynchronous. I already told that we don't use the clock between transmitter and receiver. Okay, so you may get the doubt. Yesterday I have shown you what is the difference between synchronous and asynchronous. Synchronous means from transmitter to receiver there will be a common clock. Based on the clock frequency or bandwidth, we just make the synchronization and we assign the frequency. Okay, but for asynchronous, transmitter and receiver will be there. Still we will pass the data here. Transmission and receiving nothing but write address and read address, write data and read data, we transmit, right? So whatever the mobile phone you are connecting to your laptop, so what data it is getting, suppose this is your laptop, here there is a UART protocol, UART port or USB port, external device you are connecting, your mobile phone. For your mobile phone, UART or USB we don't have. Nowadays we are using C type or B type pins like that, right? So we connect here UART to B type or C type pins. Okay, so how the transmission will be happen between these two devices? In our computer or laptop, there will be a main processor where we generates the all type of instructions, common instructions, and in our mobile phone also there will be a processor. Okay, so whatever the data we are sharing between two devices which are connected externally, this processor and this processor need to communicate each other. Okay, via this common channel wired. If you go with a wireless protocol, yesterday what type of wireless protocols we have discussed, like a Bluetooth, Wi-Fi, these all are somewhat wireless. Directly you know how it will be connected, right? Signal to signal, we have the options. Directly we will connect with the external devices or internal devices. Okay, so here block to block connection, I mean device to device connection, it will be happen through UART protocol. Okay, or USB. Here processor is a main chip where it run the instructions, and here there will be a processor, it will be running the instructions. Here we are not using the clock, so how will be without using a clock, so how we can get the synchronization between transmitter and receiver means we will have the start bits and stop bits. Okay, so whenever we tell to start the transmission, start bit will be high. Whenever start bit is high, will start or we initiate the transfer. Okay, whenever stop bit is high, the receiver is not ready to accept the data, that means we need to stop the transaction. Okay, so based on the start bits and stop bits, we are going to make the transmission between the transmitter and receiver or source to destination, like that. Okay, and coming to UART protocol is a full duplex communication. Yesterday we discussed about half duplex, full duplex, and simplex, right? UART comes under full duplex. Why? Because whenever we are USB also comes under full duplex only. USB, UART, whatever the external devices we are communicating, it comes under full duplex. Okay, why? Because both if a laptop is sending something to mobile phone is also sending to the laptop something, both can be done parallelly. The transmission can be done parallelly, that means simultaneously, parallelly, and also simultaneously bidirectional. That's why we call it as a full duplex. Okay, and configurable data baud rate. Configurable baud rate in the sense, baud rate is nothing but speed, at what speed you are going to transfer the data. If you connect the clock, okay, between two devices or two blocks, based on the clock or based on the frequency, we can estimate at what speed this transfer is working, or which rate the number of bits are going to transfer. We can have the estimation. But here we are not using clock. We use baud rate. Baud rate in the sense it just define the communication speed. Example, if you see here 9600 double one 9600 bps. Okay, so those many bps in the sense a baud rate per second. So how many bits per second, not baud rate, bits per second. So how many bits we are transferring per second, that will give us a idea on clock speed. Okay, next, FIFO buffer support in UART protocol. Not only in UART protocol, any protocol we use FIFOs. Okay, FIFO in the sense, suppose here the processor is having some data. That data it is sending to the UART. So with the from processor to UART, there will be a FIFO here. Why? Because processor works at a very high speed, but UART doesn't works at high speed. Without data loss between these two, processor and UART, because processor suppose in 1 second it is sending 10 number of transactions. Okay, but UART can't get the 10 number of transactions in 1 second, right? UART cannot send those 10 transactions to here in 1 second. It will take time. Maybe for 10 seconds, one transaction, next to 10 seconds, second transaction, next to third second, the 30 seconds third transaction. That is what the speed of UART. Okay, very low compared to the processor. So in that case, how we can send the data from processor to UART? We have a temporary storage device here called FIFO. In FIFO, we will store all the data. One by one, UART will access that data, USB or UART, whatever. Okay, so that is what FIFO. FIFOs are used to store the data temporarily without any data lossage. Every byte will be sent perfectly. It avoids the data loss. Okay. Next, error detection. In your protocol, we have error detection by using the parity bit. It is very oldest version. It just detect only, even it doesn't correct the error. But if you go forward like APB or AHB, AXI, USB, we have lot of methods for error detection and error correction. Even separate signals we have for error detection and correction purpose. But in your protocol, we have a parity generation. I think you already know the parity, right? How the parity will be generated. We have even parity, odd parity. Suppose if you are passing the data 0, 1, 1, 0, 1. If you want to use the even parity here, even number of ones should be ones must be even. That means 4 ones or 2 ones or 0 ones or 6 ones. So if it is a parity detector, even parity detector, output will be 1. If it is a odd parity detector, output will be 0. So you need to decide which type of parity you are using, whether even parity detector or odd parity. Based on that, the number of ones or number of zeros will be changed. We have that topic also, we will discuss clearly. And next, low power consumption. Mainly UART protocol is a low power. Why? Because it have very minimum number of signals. Okay, whenever there are minimum number of signals, automatically the power consumption will be low, right? Because it works at a low speed, low data, just 8-bit data or 10-bit data, mostly 11-bit data including parity. So when there are less number of bits, automatically the power consumption also low. Okay, so mostly UART protocol is suitable for battery operated devices. Okay, not more storage purpose or sending the data like for high speed transmission purpose. We never use, mostly for battery operated devices, so it will be suitable. Battery operated in the sense wherever the device we put some battery which we take like remote sensor devices will be there. So those type of applications we use uart protocol. Okay, next, simple and cost effective. Very simple. It have only fewer components, just a simple frame format, and wires also very less compared to the remaining. So it is simple and cost effective. Okay, clear till here, everyone? So what will be the advantages now for uart? What will be the advantages? Can you tell me about few advantages of uart? Are you there?
Yes, yes.
What are the advantages and disadvantages of uart? Advantages in the sense is simple, easy, no need of clock. So if there is no clock, it reduces the complexity, and reliability in data transmission, or flexible and configurable, and low power consumption. These are the advantages, not just advanced features. And coming to the disadvantages, there will be lot. It works at a limited speed or baud rate mismatches. Mostly, we will get baud rate mismatch issues between transmitter and receiver because it's not a fixed clock, right? Just we are putting some value baud rate, in the sense it's just a value at what value the data will be transferred. So we will get a lot of mismatches between receiver and transmitter. And also it supports point to point communication. It cannot be used for multiple device networks like I2C or CAN. I2C and CAN, we will connect multiple devices, one master to multiple number of slaves. But by using UART protocol, we can connect only one to one, point to point connection. That is one of the limitation. And no built if you see many, it requires the additional of hardware or software like rtss cts signals are required. So that is one of the limitation for that. And coming to the features of your like protocol, coming to the versions, we have lot of versions in your from starting 8250. 8250 is one of the oldest version, starting version. Okay, it just have the single chip serial communication, 1 byte buffer only. It transmit 1 byte buffer, and very limited in high speed data rates. And later on, 16 450 UART. So like improvement from 8 to 50. It's just having better higher data rates, but still lacking in the buffering capabilities. It is improved in speed, but still it have the substantial buffering capabilities. It doesn't work with 16 byte FIFO like that. Okay, and mostly this whatever here we got some enhancements, it will be handling the cpu, mostly processing load, and cpu, it works at a higher speed without any data loss. And next, latest versions are 1650, you got 16850. That means 128 bytes, 64 128. In 16750, we use 64, and then 128. And also 16950, it supports 9-bit enhanced data. Eventually 128 and also 9-bit characters it will be supporting. Okay, so like this. Later on, same versions, but increased in buffer sizes, 1 byte buffer size, 1 byte buffers, 128 buffers from 1 to 128, and also higher baud rate. We included a higher baud rate technology, and also RTS, CTS. Okay, so And coming to the, if you see here, FIFOs are mostly used, but you may get the doubt, why do we use FIFO? Before I said, right, why do we use the FIFO? Whenever transmitting the data and receiving the data between CPU and the UART or external device happens, FIFO stored the data before transmission and it will be sent to the UART. In the same way, at receiving side also, FIFO will be stored the data internally and before the CPU process it, it just prevent the data loss between the CPU and external device. And also it handles the flow control with RTS and CTS. So what is mean by RTS and CTS? Request to sender, clear to sender. Whenever we are sending some data, based on the stop bit and start bit, it will be initiating the transfer. Okay, so whether we can transfer the data or we can stop the data. Mostly it will operate in the flow control and interrupt handle. That means it just triggers whenever the FIFO reaches a certain threshold value, whenever it can't store any data, because of a FIFO, we already discussed FIFO, right? We have two conditions, empty and the full condition. Whenever the FIFO is in empty state, we can write the data, but we can't read the data. But whenever FIFO is in full stage, we can read the data, but we can't write the data. That means it reach maximum, it's a threshold value. Okay, so that time it will generate the interrupt handling. And also buffer sizes, your protocol increase from 1 bit to 1 byte to 16 byte, 64, 128 byte of data. So FIFOs, in this case, FIFOs are very efficient for high speed communication purpose. Clear till here? Any doubts?
Prasanti, one doubt, like you are yesterday we have just read that UART is simplex, sorry, half duplex. Here it is mentioned that it is full duplex. Like, I mean, we were telling that only AAXI is a full duplex, but because it has channels for everything. But
Uh,
here,
Yes, actually, UART and USB also full duplex, because these are ports, right? So whenever we are transmitting the data, even if you see, whenever we connect a mobile phone to the laptop, we can send the data parallelly. Both processing will be happen. This laptop processor and mobile phone processor both will communicate parallelly, right? Not one after another. So in that case, if you see, both will work as a full duplex, and AXI also works as a full duplex. Because in AXA we have the number of channels. Uh, if you see in I2C or SPI, APB, AHB, to do the write operation and read operation at once only, both are enabled. Both are not enabled at same time. If write is enabled, read is disabled. If read is enabled, write is disabled. So bidirectional transmission can be happen, but not simultaneously. But in AXI, this USB, UART, both can be done parallelly, simultaneously. Yeah. Okay. Any other doubts, others? No?
One doubt I have. This while we are creating that FIFO for the transmitter and receiver, the size of the FIFO should be same for both the transmitter and receiver. The
The
FIFO.
size of FIFO based on how much memory you are going to transfer based on the size.
Okay.
5 bit size means 2 plus 5 bit FIFO we will create. 2 power 5 number of locations it should stored, right? Based on your memory data transmission, clear the FIFOs.
Okay.
Um, Akash, any doubts? Lahari, Manoj, Murlidhar, Narayana, Ranjit, Roshni, Shweta, Tarun, any doubts?
Is there any bus like between the port and again processor?
Bus internal, this is not bus protocol. Yesterday we discussed, right? APB,
Yeah,
HB,
it's a peripheral.
those all are bus protocols.
So,
Obviously,
so
the processor to UART, it directly, it not connect directly through bus only. It will be connected here.
yeah.
Suppose here we have a UART port in your laptop, and this is our mobile phone. For mobile phone, we have a port. You are to port here, it will be communicating, but whatever we are transferring the data here, this processor need to send the instruction, and mobile phone processor also need to send the instruction. The processor will be communicated every single line of the whole entire architecture. There will be lot of signals, every signal will be communicated with the processor, right? So like this, in the next session I will explain you the full detailed on actual processor whatever we use in industry. Okay, by next week I think it will be clear, because okay, by next week I will show you. Okay,
Yeah. Okay.
so this processor to interconnect here, it will be communicated through here, processor interconnect, and through interconnect to here. This interconnect will be at processor side. We use high speed interconnect called AXI. At the peripheral side, we use APB interconnect, low speed interconnect. Between what is there, like high speed to low speed, how we will connect, bridge will be there, AHB to APB bridge or AXI to APB bridge. So from processor to processor, internal there will be lot of things it should be communicated, and then through the port it will be sending the data. Again here also directly it will not connect to the processor. It will be IO peripherals, and these two IO peripherals, lot of interconnections will be there. To that interconnect, the main processor will be communicated.
Okay. Yeah, got it.
So here, suppose this is a UART and this also UART, both are UART. If you think, suppose if you think it as a scanner or printer, obviously for scanner or printer we have USB ports, right? So to transmit the data here, we are transmitting the data serially here between this wire to this wire channel. So how we are transmitting the data? This is what the frame format we need to follow. Okay, first there will be start signal. Start signal in the sense it will initiate the transfer. If you see here, start bit logic 0, whenever start bit logic 0, this bit is 0, it will initiate the transfer, so that D0, D1, D2, D3, 4, 5, 6, 7 or number of data bits, D0 to D7, total 8 bit. So we are passing the 8-bit data. Here we don't have addresses. Remember everyone. In UART protocol, we don't have the address, just a data transmission only. But in I2C, SPI, APB, AHB, AXI, we have the address. Why? Can you tell me anyone? Why it will be?
Multiple slaves.
Okay, multiple slaves is different. Okay.
Because it communicates with the processor.
Okay. Any other answers?
Because it
The
communicates with the
buses
processor.
connected is number of ports. That's why.
Okay. Okay, see here. If you observe within a computer, here is a computer. In computer, SOC architecture is there. in SOC architecture, there will be a processor cores, GPU processor, memory blocks, and graphic processors, DSP processor, and middle there will be a interconnect. These all are high speed related, the memory controllers or processors or GPUs, everything. And here there will be low power peripherals, peripherals in the sense UART connections or USB connections, or even these keyboard, mouse pointer, any Wi-Fi module, Bluetooth or GSM module, whatever the low power devices are there, these all are connected uh, down. Okay. Now your processor is communicating with this low power device. So processor works at a high speed. That's why we used AXI, and these low power works at a low speed. That's why we use APB. Before you to ask, right, whether it have interconnect or not, bus, this whole bus, this is nothing but the bus. Through the bus only, this processor and here it will both will be connected, and from here to here also, here to here, every block, this block will be communicated here, this block will be communicated here, like this. But it will be most confusion if I draw all. So like that it will be communicated to everyone. Actually what we are communicating here, suppose the processor is communicating with a Wi-Fi module, what actually it will communicate? Processor means what? It have the instructions, right? Instruction set, everything will be done through the instructions only, arithmetic and logical instructions. Suppose we have a lot of instruction set architecture where we write in a immediate instruction, register type, branch type, jump type, suppose add register 1 comma register 2. If you remember assembly language program, this is also a lot of complex program, subtraction or even jump, increment, decrement, if else also we can write. All these things can be done through the instructions only. So here what actually we are doing, we are writing the registers, doing some operation between the register and storing the value to the register. So whatever the data is storing here, these data are sending to the USB or Wi-Fi module or GSM module. That means particular data, particular address. Okay, suppose from register R1, here processor register R1 data, we are going to store here in a particular address, and in that particular location we are storing the data. That's why address and data requirement is there within the chip. Okay, but here UART to UART, this is our laptop and this is a printer and scanner or whatever. Are we going to store from laptop to here? We are not storing the data here. We are not doing handshake mechanism, or we are not reading and writing the data here. Okay, processor to internal chip means we need to read and write the data, or we need to store the data in a registers like that, or in addresses, whatever. But here just transmission, you are transmitting processor to this processor. Okay, that's it. You are not going to store any data by using UART. Of course you store the data, but in which case you will store data? Suppose here UART to UART communication is there. What is the work of UART to UART? Just a transmission only. Okay, after getting to this particular point, this data should be sent to the processor here. Okay, suppose here UART is there, this UART will be there in a some peripheral IO device. This UART is communicating with some GSM module. Okay, this GSM module need to communicate with the processor. How it will be communicate here? Again there will be interconnect. Again there will be interconnect. This side APB interconnect will be there, and this side AHB interconnect will be there. And now the handshake will be happened. That means in this particular GSM there will be write address, write data, read data, and here processor also write address, read address, register data, everything will be there. So that's why within the internal chips mostly we have the addresses and the data, even in APB or AHB, AXI, I2C, SPI, PCI, whatever you take. But for these port to port we don't store any data. We are just transmitting the data from here to here. That's why if you observe here in frame format, we never have the addresses. We just have the data because only data transmission will be done using uart or even USB. Did you got the point, everyone?
Yes, ma'am.
And here if you see here, parallel data transmission, one uart is communicating with another uart, one computer, second computer. Here also parallel data transmission. So why it is happening? If you, I think you will get the clarity. You already got the clarity, I think. Can you tell me here why we are using parallel to serial transmitter? Suppose if you see here, your transmitter, here we are using parallel to serial, and here we are using serial to parallel. Can you tell me why we use that?
Because data coming from the CPU is parallel, we have to convert it into serial data to send it across the transmission line.
Okay.
And from the receiver side, the data will be serial. It has to be converted back to parallel for the processor to do further processing or whatever it needs to do.
What is your name?
Brian,
Okay. Others, any answers? Okay, see here. I already told. This is what the computer. For the computer, we have a UART port. To get this data to UART port, suppose this computer to computer is transmitting. Here somewhere we have a processor and remaining a system on chip. Okay. So this is what the communication between computer to computer, and serially it is transmitting, but internal processor or memories or remaining blocks, they doesn't work with the serially, right? All the data will be done working with a parallel communication only. Okay, for that purpose, at this particular port, at this computer, at this point, we will get the parallel data only. But to communicate, to transfer same parallel data to the next whatever outside connected device is there, to communicate with that, we need to convert it to the serially. Why? Because UART or USB, these works with a serial communication only. That's why at a transmitter side, we use parallel to serial converter. So here the data is converted serially and serial data is sending to the next computer. But this computer again, it doesn't understand serially, right? We need to transfer in parallel only because processor works at parallel. Okay, and even A8PB, AHB, all interconnects works in a parallel only. That's why we need to convert again serial data to parallel data. This is what exactly the S4C protocols works outside the device and internal the components. Everyone got clarity or need to explain again?
Ma'am, can you please explain it again?
Okay. This is your laptop and your mobile phone. Okay. In your laptop, yesterday we have seen system on chip, right? Every laptop, every mobile phone, or any digital logic circuit, it contains some chip, the processor. We call it as a system on chip nowadays. Okay. So what will be there in the system on chip? Every system on chip commonly, I'm telling the common blocks only, it contains processor, it contains graphic processor and memory blocks. Yesterday I have shown you north bridge IO, south bridge IO, PCI slots, everything, right? And there will be some IO peripherals. Okay, IO peripherals in the sense uh, like IO interconnects or these type of UART keyboard, mouse pointer, or Wi-Fi, GSM, Bluetooth, fuse, or video related, image related mostly comes under high speed only, not low speed. Machine learning techniques or AI course, everything comes under high speed. This side comes under low speed, timers, embedded sensors, or some any IO peripherals comes under low speed. Okay. So in the middle, what will be there? Interconnects will be there. Interconnects are nothing but a bus signals, right? Why? Because bus means what? Every data will be sent parallelly, not serially. Bus in the sense parallel communication. Okay. What are the bus protocols we have for parallel communication? We have AXI, APB, AHB. Yesterday we discussed what is the difference between AXI, APB, AHB, right? AXI works at a very high speed because of its features. That's why at processor's side, because processor, memory, these image processors or video converters, everything works at a high speed. So AXI will be used here, and APB works at a low speed. APB will be used here. Okay. And also we have these same blocks in mobile phones also will be there. Processor, memory units, graphic processors, and here IO peripherals, low power devices, everything will be there in a mobile phone also. And there will be interconnect also, bus. Why we are using bus here? Processor need to communicate with every block here to here. These blocks will be communicated from here to here, and these blocks are communicated from here to here. Everything will be happened in parallel communication only, from here to here. Here, through interconnect, the data will be sent from high speed to low speed, high power components to low power components. Okay, so that's why here we are using AXI and here we are using APB. Okay, so within a chip we have some SPI, I2C, like that. Within a chip we will communicate those things. Just leave about that. Now you want to transfer this data, your computer data, to your mobile phone. Suppose in your mobile phone there are some videos or images are there, right? These videos or images you want to send to the computer. You are just sending, okay, using wire. You are just sending to the wire. So whatever you are sending here, this is what USB port, USB or UART port. And here we have a B type or C type charger cables will be there. Through that cable to cable, we are transferring the data. Okay. So this is what serial transfer. Here you are transferring the images or videos. Okay. Images or videos. Another thing, can you tell me what is the difference between encoding and decoding? Encoding and decoding.
Like we are reducing the number of bits is encoding, and like encoder it's like multiple to low number of inputs. We can multiple inputs to we can convert into low number of inputs.
Okay.
Decoding is
Decoding.
like with the less number of inputs we will convert to the actual information, more number of outputs.
Okay. Next.
Encoder is used at the transmitter end. It's used for transmitting data. And decoder is used at the receiver end.
Okay. Okay, see. Encoder is nothing but encoder is nothing but suppose you're typing some message in your mobile phone. Okay. Hi message you have typed in your WhatsApp as hi. This is your mobile phone. You have texted to your friend. Your friend also receiving same hi message. Or if you are sending some video, your friend also receiving same video or image. Okay. But this hi message, how it is directly transferring to your friend? What happening internal system? First of all, whatever you type in your WhatsApp through the software application, the hardware will understand that message in a binary format. That's what we call as a encoding. Encoding in the sense actual data, the physical data, whatever the message or video or audio or even image, that will be transmitted into the binary. How it is transmitted into the binary? Normally ASCII values, if you remember, the special characters or the alphabet, high level, I mean uppercase letters, lowercase letters, everything will be converted into the binary. It have particular ASCII value. Even for images, video, whatever, it will be converted into the binary. So this is your mobile phone processor. Okay. And it will be sent to your friend mobile phone processor. And here this processor will understand this binary data. Processor to processor understand binary data. But again, if you get this binary data as an output, instead of hi message, H is converted into binary value, I is converted to binary value. Instead of not getting hi message, if you get a binary value, can we understand? We can't understand, right? So here decoding will be happened. That binary value will be decoded again in the processor, and the output will be giving to the as a high. So that how the encoding and decoding will be happen here. Okay. In the same way, here you are sending some image or video to your computer, your mobile phone to your computer. This image or whatever the physical data will be converted into the binary here, one by one bit, each bit using uart or USB. The data will be converted into the binary and transmitting like this. Nowadays we are using USB protocol. It is very advanced protocol. We don't have any start bits, stop bits like that. We have direct clock, so directly clock will be transmitted. But this is very oldest version. How you are transmitting the data from start your computer to stop your mobile phone, or your mobile phone to computer, how it is transferring D7, D6, D5, D4, D3, D2, D1, D0, like that same bits. However, I have written here, like that it is sending from here to here. That is what your protocol. Okay, just sharing the data. It is not storing anything, just communicating only. Okay, now whatever this data you got here at this particular port, it should store in your computer, in your drive, in your software, whatever the drive we have, C drive or D drive or whatever the storage, you are going to store the data here. So this particular data will come to the USB first and then to your memory. How it will be come to your memory? Directly it will communicate to your memory, or with small peripheral to like this. Here this whatever serial data we got, it will be converted parallel data. Okay, so this parallel data through APB is a interconnect here. This parallel data will be sent to here to your memory. Okay, here AXI will be getting, it doesn't store directly, right? Anyway, every data will be communicated with your processor and with your graphic processor. Everything is connected each other. Okay. So this serial data is converted to parallel now. Whatever the memory is there in your memory hardware, it will store the data. Parallelly, the cores will work. That particular instructions will be generated by the cores, and in your memory, it will be storing the data. So the parallel data will be stored here. Did you got the idea now? How it is storing into that particular registers, address, data will be getting here. Clear? The parallel communication and serial communication.
Uh, at the beginning, you told that it will be stored in FIFO. So that FIFO standing inside the IP, peripheral IP stack.
FIFOs will be there not only if you're not in a IPs, internal connections we'll have the FIFO. Here I just drawn now just overall. But if you see your transmitter, only transmitter block, how it is final state missions, PSO, parity generator, and start bit, stop bit, mux, and here is the receiver. This data will be sent to the FIFO. We will use lot of FIFOs here, nearly 1 lakh of FIFOs we use within a system on chip. Every connection we use the FIFO memories. Just buffers. FIFOs are nothing but just buffers. We use lot of buffers each stage.
Yeah, so here the processor will communicate to the AXI and then AXI to APB. And then inside the UART IP, we will have the FIFO. There it will be stored. And then UART work on that to send it.
Yes. Yes.
Okay, so from UART to the socket, you're telling again some connections will be there, right?
Yes.
At the socket, we can't, because on the motherboard, so many things are there.
Mm.
So our IP will stand at one place, which
Yes.
is not near to the port.
Yeah. I will show you. Wait, exact as see how it will. Any other doubts from others?
Hi, ma'am.
Yeah. Hi.
Uh, can we use the FIFO for connecting the I2C and SPI also?
SPI. See, FIFOs all are interconnections. So we use FIFOs there also.
Okay.
Ma'am, as you said, we don't need any address. For example, if I'm copying the data from my mobile to laptop, I'll assign a location. It is not an address, right? Or else,
Wait.